As its name implies, analysis of variance analyzes the variances of the data to determine whether there is a difference between the group means. Think back to the T-cell count example. This line represents the average T-cell count for medications 1, 2, and 3 combined. With ANOVA, you can determine if the variation of the means is large enough relative to the variation of observations within the groups. To do this, you calculate the variability between the means and the variability of observations within each group, and then calculate a ratio between these two measurements. If the between-group variability is significantly larger than the within-group variability, you reject the null that all of the group means are equal. So, you partition out the variability using sums of squares. For ANOVA, you calculate 3 types of sums of squares: between-group variation, within-group variation, and total variation. Let's examine each of these. Between-group variation is also called the model sum of squares, or SSM. Here's the formula. To calculate a measure of variability between the means, you take the difference between the mean for one group and the mean of all the observations, square it, and then multiply it by the number of observations for the group. You do the same thing for the other groups and then add each summation to get the model sum of squares. Within-group variation is also called the error sum of squares, or SSE. To calculate a measure of within-group variation, meaning within each medication, you take the difference between each observation for one group and the mean for the group, square each of these values, and add them together. You do the same thing for the other groups and then add each summation to get the error sum of squares. Total variation is also called the total sum of squares, or SST. To calculate the total sum of squares, which is a measure of the total variability in the response variable, you take each data point and calculate the difference between the observed value and the overall mean. You then square each of these differences and add them together. You do the same thing for the other groups and then add each summation to find your SST. This diagram shows a slightly easier way to understand the breakdown of variability in ANOVA. As you can see, SSM and SSE represent pieces of the total variability. Remember that the SSM is the variability explained by the type of medication, and the SSE is the variability not explained by the type of medication. You want the larger piece of the total to be better represented by what you can explain versus what you can't explain, which means you want the SSM to be the larger of the two pieces. The SST represents the overall variability in the response variable, T-cell count.